Hello everyone, I welcome you to this new video. Okay, we are making a video on MT6357crv boot sequence. Okay, so before we dive into the video, I have something to say because this video might look a little bit boring, you know, because it's very long, it's very lengthy, so and people need very short videos, you know, quick fix. It is what I understand, but there are times that you have to understand how it works. Okay, there are times you have to know what to do so that even when you are not, or when you do not see that solution per se, you can know how to troubleshoot one after the other. So that's why I keep making these type of videos, because I really want you to understand. Because by knowing how it works, by knowing the boot sequence, the tracing, the troubleshooting one after the other, the lines by lines, you will be able to know where the fault is coming from. Okay, so if you can exercise patience and watch this video to the end, I believe that you will learn a lot. Okay, you will learn a lot. So now we have here MediaTek MT6357crv boot sequence. This is the most common used chip. Okay, this is the most common used MediaTek chip, followed by 6358. Okay, so now this is the boot sequence, how it works, the step-by-step troubleshooting in case your phone is dead, or the phone might be restarting, or the phone is not coming up. No matter the readings it gives you, okay, no matter the readings it gives you, you can know where to start from and the lines to check. So I've made a boot sequence here indicating the lines that you will have to test if your phone is not powering on. Okay, so we have 4 IC here. We have a DC to DC converter, we have here our power IC, we have here our CPU, and we have here our external buck converter. Okay, I've made a video on external buck converter. In that video I explained deeply on how this external buck converter works. Okay, so if you haven't watched that video, please do well to go and watch it. Okay, now this is our DC to DC converter. This is our charging IC, and we know that it is our charging IC that supplies power to the power IC to turn on the phone. Okay, so in most phones, without the charging IC, your phone will not turn on. That is, your power IC will not boot. But there are some other phones that without the charging IC they can still boot, like iPhone and like other. There are few MTK that it is not using the power IC, is not using the VPH, it's rather using the VBAT. Okay, so the VBAT, the battery from the voltage from the battery can power up the phone. But in this type of chip, which is 6357, in this type of circuit, it is the DC to DC converter that sends 3.7 to 4.2 volt to power IC. Okay, so I'm just going to explain these things briefly to you so that you can understand. So now, the first place to check if the phone is not powering on is your DC to DC converter, that is your charging IC, and there's always a switching coil here. Okay, we have three major coils in phone. We have buck coils, boost coil, and then switching coil. So in this DC to DC converter, the coil that they use here is switching coil. Okay, so we have here our switching coil, and we also have here a boot a boot cap. There's a capacitor that is connected in series. We all know how this works. Okay, if you don't know, go and watch my previous videos. If you understand, I explained this. Okay, so you will check this capacitor. Okay, because if this capacitor is damaged or is shorting or is missing, this VPH will not generate its voltage. Okay, so this is the coil that they use. So when you get your 3.7 to 4.2 volt from this coil, now This coil, this VPH line, distribute voltage to different circuits. It will distribute voltage to your to your network section, to your audio section, to your Wi-Fi and Bluetooth, to your power IC, light display. So it distributes voltages to different circuits. So one line of the VPH comes to our power IC. Okay, so this is the line, and immediately it comes to the power IC. This is the line. The first line that we enter the power IC is called V6SMPS. Okay, this is the first line that it will enter. But I want to explain something to you. There is always a resistor. Let's say there's always a 0 ohms resistor that is connected in series in the first line. So if this resistor is faulty, if this resistor is burnt or the resistor is removed, your power IC will not receive the voltage. Okay, now all these lines that enter the power IC, these lines are very, very important. If one line is missing, the phone will have issue. For example, this VPA, that is voltage for power amplifier. If this line is missing, it's not entering the power IC, there will be no network in your phone. Although the phone will turn on, but you will not get network, because this line is responsible for supplying your network circuit voltage. Okay, so like if this V core is missing, your phone will not turn on. V Pro, your phone will not turn on. Okay, so even the VS1, this is your high LDO line, it will not turn on. So all these lines, these 5 lines are very, very important. Okay, we have 6. Okay, there are 6 lines here. 1, 2, 3, 4, 5, 6. Okay, so these lines are very, very important. So you have to check this resistor. That is after checking your DC to DC converter VPH coil, the next line to check is your resistor. It's very important, please. It's 0 ohms resistor. If this resistor is missing, you can jumper it. Okay, so now this line will enter this power IC through here, and there's always a capacitor that is connected in parallel, and this capacitor is used as a filtration caps. You will see that caps around that surround the power IC. These are the caps. Okay, these caps is very important. Okay, it helps to filter the voltage, the current, sorry. So now after the first line, there's always another line that goes into the power IC, still the VPH line. So now when the VPH line comes, it will distribute voltages, it will distribute lines into the power IC. So if any of the line is missing, your power IC will not work. So we have here V6 Pro. This is voltage for your processor. So this line goes directly to your CPU. So these are the input lines, and we also have output lines. Okay, garbage in, garbage out. Anything that have input, there has to be an output. So this is our output lines. So we have your V6 core. Okay, V6 for VPA, V6 modem. Okay, this also goes to your CPU, and it also goes to your network section also. So we have your VS1 high LDO. Okay, so these are the input lines. So you must ensure that these lines have entered the power IC very well. Okay, but let me say something. You see all of these lines, they have positions. They have each of the line have different balls under the CPU, sorry, under the power IC. So if any of the ball is missing, it will affect the phone. Okay, it will affect the phone. So you have to check all of this, that there's no line that is missing. So after that, I just want to explain everything briefly. After that, after ensuring that there is an input voltage that is coming from your DC to DC supply, that is power IC, DC to DC converter into your power IC, how will you know? When you test this resistor is working, you get a 3.7 volt from this side, and you also get your 3.7 volt on this other side. You test this capacitor. This capacitor will tell you that these lines have successfully entered your power IC. Okay, but these capacitors will not give you guarantee that all the lines are connected. So how will you know that one you have to leave the power IC? But you should not just jump and to leave the power IC. You have to ensure that you do all the testing. Okay, you can only leave the power IC if these output voltages are not generating, and before you lift it, there are other lines to also test. Okay, after this, the first line that you will check is your power key. Okay, when the power IC gets the input lines, the input voltage, so now the first line that is going to generate voltage is your power key. So you go straight to your power key and check, and the voltage that you get in your VBAT, you get it in your power key. Okay, 3.7 volts. This is our power key. Okay, this is our power key. So now, for a lot of us don't know where to locate this power IC and how to test these capacitors or how to check it. So let me show you on schematics. Let me switch it to schematics and show you where these lines are connected. Okay, I opened these schematics with bitmap. I've combined it with bitmap. Okay, so this is our power section, PMU bulk. This is our bulk section. So let me zoom in. So this is our input line, V6. This is coming from our charging IC. So when it comes, it will miss a capacitor, a filtration cap, and then this line will go to this resistor. This is the resistor that we are talking about. If you click here, it will lead you to this bitmap. It will show you where the resistor is located near the power IC. Okay, this resistor is actually 1 ohms, but you can still jumper it. The resistance value there is 1 ohms. Okay, so this is the resistor that I was talking about. This resistor, if it is open or is damaged, the voltage will not get into the power IC. Okay, we also have this line enters this power IC through this section. Okay, SMPS. So now this is the first capacitor. Now the next line, the second line, enters this V Pro. Okay, voltage for processor, and this is capacitor, second capacitor that I was talking about. So there's another line that enters V core section, and this is the capacitor. Another line enters V modem, and this is the capacitor on it. Okay, so now this other line VPA, it has a capacitor here, and V6 also has a capacitor here. So now let's zoom in on this bitmap to see where these capacitors are located. You see these 5 capacitors. These are the capacitors, and if you click on any of the capacitors, it will show you that the 5 capacitors are connected. Okay, so now this is the capacitor. These are the capacitors that I was trying to explain to you. So you always find these capacitors that surrounding the power IC. Okay, now so let's move to our block diagram. So after that, we have here our power key. This is the first line that you test. After these lines, our power key carries 3.7 volts. It can take up to 4 point something volts. Okay, the voltage you see on your VBAT, you will definitely see it on your power key. Okay, so this your power key must generate voltage. If you don't get voltage here, your phone will not be able to turn on, because this is the line that you will bridge to ground. Okay, and then it will trigger up the phone. So after the first power key line, the next line that you will test is your VREF. This is voltage for reference. This is your reference voltages. Now you will test this voltage. It carries 1.2 volts. If this voltage is not generating, your phone will not turn on, and this line is not going to not going to anywhere. There's always a capacitor on these lines. Okay, I've not put those capacitors here because there's no space. So there's always a capacitor connected to each line. There are capacitors connected to each line. So you will test those capacitors. If this line is not creating, work on your power IC. Don't go to anywhere. Work on your power IC. Can reball it. Then the next line you will get there is your 2.8 volts, which is your VRTC. This stands for voltage for real-time clock. Okay, this is your voltage for real-time clock. You must check this voltage. If this voltage is not generating, your phone will not turn on. Your phone will be in a dead condition. Okay, it will be in a dead condition. So now this is 2.8 volts. This, you must get this 2.8 volts on this VRTC. Okay, and let me tell you one thing also, that this line can be short. Okay, this line can have short circuit. So if any of these lines, these 3 lines, and the rest of the lines is having short, your phone will not turn on. Sometimes your bulk voltages will be fluctuating. Sometimes it will not even generate. Okay, because the short there will not allow the voltages to pass to this other side, and it will not allow the voltage to be stable. You understand? So you must test your VRTC, voltage for real-time clock. You must get your 2.8 volts. If you don't get your 2.8 volts on this line, check if the line is shorting. If the line is shorting, simple. Use your bitmap, locate the component that this line is connected to, apply your Rosen flux. Then after that, you inject voltage. Okay. After that, you try to connect your charger Immediately you connect your charger, you will see that the faulty component there will melt, and you will remove it, and then your phone will turn on. Okay, if the light is not shorting and you don't get this 2.8 volts, I will say that you should reboot your power IC. Okay, now this is another line. The next line that you check is your VXO. This is voltage for crystal oscillator. This voltage is 2.2 volts. Okay, this voltage is 2.2 volt. You understand? So you must check this voltage. This voltage is very important. So this is the next voltage you check. Check this line. If you don't have short in this line, check voltage. If there's no short, check voltage. Then if the voltage is not coming, that means you have to reboot this power IC. So now the next line there is your VAUX. Okay, this is your auxiliary voltage. Okay, so this line is carrying 1.8 volt, and this line goes into have a connection with this line also, because this line is also connected to your crystal. Okay, your crystal is there, so this line is connecting to your crystal. So now if this line is shorting, or your crystal is not working, or there is no divided circuit on your crystal, because inside your crystal there is an NTC. Yes, there's a negative temperature coefficient thermistor that is inside your crystal. So if that thermistor is faulty, or the divided circuit is not working on your thermistor, that is on your crystal, this line will also have issue. So as you are checking on this line, you also have to check this line will lead you to your crystal, so you will check your crystal. Okay, so now these are the 5 lines that you have to check first. If all of this line is okay, therefore you move on. Okay, now if any of this line is faulty, the rest of the line will not work. If any of this line is not giving out voltages, or is not is shorting, the rest of the line will not work. So it's step by step. Okay, so now these are LDO's line. So let me quickly show you where you can find these lines on schematics. Okay, so for us to locate these lines, let's go to our power IC section. This is our clock section under control. So we will find our power key under this control. So when we click on this power key, it's going to lead us to another page. So let's next it. So when we next it takes us to this side key section. So when we follow this line, our power key line, it will take us to this, it will connect to this line. So we will see 1K resistor in this line. If this resistor is open, or if this resistor is faulty, is burnt, your power key will not work, so your phone will not turn on. So always ensure that you check this resistor if your power key is not giving you any voltage. Okay, so now this is where you can locate the power key. So the next line is our voltage for reference. So let's go to our LDO section. So now we've located this line VREF, so it's 1.2 volts. You follow this line. So now there's a capacitor. This is a 1.2 VREF. There's a capacitor that is connected to this line. So when if we click that capacitor, it will show us where the line is connected on our bitmap. This is the capacitor. So let's follow this capacitor. Let's click on this capacitor. Now this is where our capacitor is located. Okay, so when we click on this capacitor, this is how it is connected. So if this line is short, your phone will have issue, it will not turn on. So you check this line also. Okay, so now the next line, still on our LDO section, the next line is our VXO 2.2 volts. So we also check this line, 2.2 volts. There's a capacitor that is connected on this line also. So this is our VXO 2.2 volts. So now when we click on this capacitor, you see where the capacitor is located on our bitmap. Okay, this is the capacitor, it's connected to our power IC. So the next line is our VAUX 1.8 volts. Okay, you can also check this line also. The way you check those lines is the same way you check this line. This is the capacitor. Okay, so now the last line is our
VRTC, okay, voltage for real-time clock, and you'll find it on our clock section. So this is the line. When you click on this capacitor that is connected to this line, it will lead you to where that capacitor is connected to. Okay, so now this is the capacitor. We click on the capacitor and it takes us to this capacitor.
So after that, the coil is the induction, the inductor, this thing lines we will generate. Okay, we have your modem, vpro, vpa, and vcore, and vs1. Okay, this is your coil's line will generate. So now this line this line is modem. It will generate voltage 0.6 to 1.2 volts. This voltage for vpro will generate. After that, vpa, and you know that this line is not going to cpu, it's going to your 4G. That's your network section, your 4G IC. Okay, so after that, if this line is faulty, your phone will still turn on. Okay, your phone will still turn on, but you will not have network if the line is not giving out voltage. But if this line is shorting, if this VPA is shorting, your phone will not turn on. Okay, so after that, you have here vcore. This is a very important line. This line will be having beeping. It will beep, but it's not shorting. So you have to check the value. Why is beeping is it will also give you value. So after that, we will have here our next line, VS1 2.0 volts. This is our high LDO, and this high LDO, it comes out and also goes back. When it enters back into the power IC, it will go and activate the low LDO section inside your power IC. So now, if this line is faulty, your phone will not turn on. Okay, so now let me this high LDO, this external buck converter, and this our LDO VA12, this line, I explained how this circuit works. Okay, I have a video, it's a recent video, okay, of how to troubleshoot this external buck converter. So I'm not going to explain it again. I just put it here so that you will understand. If any of this line is faulty, it's not working, your phone will not work. Okay, so now let me show you these lines, where you can locate these lines on your schematics.
In order for us to check this our inductors, let us go to our box section on our power IC. So now this is the output of our power IC. Start from this box. So this is the first box. If you click on it, it will take you to this vpro. Okay, it will take you to this box. So this is where this box is located when you combine your schematics with your bitmap. So now that is the first box. Okay, so now the second box coil will be our V core. Okay, so now let's move to our V core so that you can know where it is located. So this is the second one, which is our V core. If you click on it, it will show you where this V core is located, still around the power IC. Okay, it has the value of 0.326. So now this is the third coil, V modem. If you click on it, it will show you where this V modem is located. This is the V modem. Okay, so now the next coil there will be our VPA. Okay, when you click it, it will still show you. So the last coil will be our VS1, that is high LDO. When you click it, it will show you where the coil is located. So these are our output coils. This is the output lines that the power IC send out voltages. Okay, it will always meet coil. So now this is our LDO sections. Let me show you one thing. Okay, there is where our VS1 comes out, it one line of our VS1, that is our high LDO, it would enters back into our power IC. Okay, and then turn on the low LDO section. Let me show you this VS1. This is the coil of it. So it comes out of here, so it goes to our external buck converter, but also comes back into our power IC, which is our LDO section. This is the line, and then it will turn on the low LDO, that's our VS2 low LDO. Okay, So it comes back into this power IC still on our LDO section and turns on this section. Okay, so that is how or where you can see our buck coils.
Okay, so the rest of the line, this is our LDO, low LDO. Okay, this is the circuit. So this line is very, very important. When this line VS1 comes into this external buck converter with 2.0 volts, this external buck converter will regulate it, and then it will send out voltage into this coil. There's a coil here, 1.3 volts, and this line will goes back into your power IC or inside your power IC to your low LDO, to your LDO circuit. Okay, to your low LDO circuit. Now this line, this IC is very, very important. This IC will regulate and then step down to 1.2 volts and send to your CPU. If this line VA12 is missing, your phone will not turn on. So I explained how this buck converter works. I'm not going to explain it again. Go and watch that video. I explained deeply on how to troubleshoot this buck converter. So after that, we also have other lines that you will have to test if your phone is not turning on. Now these are the lines that is responsible for turning on your phones. So you will check these lines. If any of this line is missing or is shorting or is not generating voltage, your phone will not turn on. Okay, but there are some other minor lines that if it's shorting, it can also affect your phone. So I'm showing you the major lines. In that other ones, you have to lift the power IC to take your ground readings, okay, your GR readings. So now we have another line, VS RAM. Okay, VS RAM Pro. This is your voltage for RAM. I also connect to your processor. That's your CPU. It's 0.8 volts. If this line is missing or is shorting, your phone will not turn on. Check this line also. We also have your VIO 1.8. Okay, this line is very, very important. This line connects to almost all the ICs on your phone. So if this line is shorting or is missing, your phone will not work. So when you have a dead phone, these are the lines to check for shorting and for voltages. If it's shorting, any of it, your phone will not turn on. Some people, if they have a phone that is having short, they will just quickly rush and remove the power IC and change it or reball it. Meanwhile, the line is still shorting. So when you have a phone that is dead, don't just rush and remove the power IC. Just rush and check these lines, okay? And if you keep working on this particular model, you will know where these lines are located. So this is 1.8. This is voltage for input, and this is our input and output voltage. Okay. So this 1.8 volt is very important. You have to check this 1.8 volt. Very important line, please. So after that, we also have here our VEMC line 2.8 volts. Check this line also. These are LDO's line. So I will show you where you can find it on schematics. So after, we also have your VIO, voltage for input and output. So this is our 2.8. We have two VIOs. We have 2.8 volts and 1.8. These two lines are very important, but this is the major one. So this VIO is connected to other circuits. Okay. So also check this line also. After that, we have your VDRAM. This is our voltage for RAM. This voltage goes to our RAM, 1.2 volt. Check this line also. It's coming out from our power IC. This is our LDO's line. So after, we also have VUSB line 3 volts or 3.3 volts. This line goes straight into our CPU. It's very, very important line. If this line is shorting, your phone will not work, your phone will not turn on. Okay. So after testing this line, I will show you two major lines that will communicate between power IC and CPU. Now it will tell CPU. Now after that, power IC will tell the CPU, okay, I've sent all the, I'm done with my work. I've sent all the voltages to you. Now it's now left for you to tell me what to do, because this power IC depends on our CPU. This is our processor. It's the main chip. This is the brain of our phone. If this chip doesn't notify this power IC or doesn't give permission to this power IC, the power IC will be dormant. So now let me show you one line that the power IC will use to tell the CPU I am okay. Now when you test this line that I'm going to show you, and you get that 1.8 volts, it means that all these lines are okay. The power IC is okay. So now we have here our reset line. If you can see the arrow, it's coming from our power IC straight to our CPU. Okay, but before this reset line, there's also one line that is left here. Okay, there's also one line that is left here. Now this is our Vox. This line is our 2.8 volt line. Okay, you will check this line. It's coming from our power IC, still our LDO line. It communicates between power IC and CPU, 2.8 volt. Okay, now this is our power IC line, LDO. So you have to check this line. I brought it here, I put it here because there's no space to add to this other side, so I put it here. So now this line is very important. Check this line also. After that, we have here our reset line. Now this power IC tells our CPU, man, I'm done with my work. Okay, so now tell me what to do, because this power IC depends on our CPU. So now our reset line, 1.8 volts, you see here reset line. And where will you find this reset line? You will see this reset line on our power IC section. That is our control section. Inside our power IC, we have 4 sections. We have here, you have buck section, we have LDO section, we have control section, and we also have clock section. So if you don't call it control section, you can call it housekeeping, HK, housekeeping. You see the HK, that's housekeeping section. It's still our control section. So when you go to our control section, you will see this reset line. So now when you test this reset line, you might see a resistor in between, or a test point, or a capacitor in between. Depends on the models. Now this line that I'm explaining to you, they also you will find them in other models that is not this MT6357, but in a boost sequence. Okay, I'm showing you these lines in a boost sequence. Okay, this line might be mixed up in another model. So now this reset line is 1.8 volt, tells this our CPU that the power IC is okay. Now there's another line that is called watchdog. This watchdog is from our CPU to our power IC. It's still 1.8 volts. Now this is the line that our CPU will send back the notice to our power IC. It will notify our power IC, okay man, I've done the clearance, everything is okay. Okay, now you can work, you can boot up very well. So now this watchdog signifies that the CPU has given approval to our power IC. You understand? So this watchdog will be 1.8 volt. If you don't get this 1.8 volt, that means these lines, there's a problem in these lines. So sometimes if you just want to do a quick work, when you get your power IC, when you get your phone that is dead, you can also, if you don't want to stress up yourself, or you know where to start, you can also rush to this reset line or watchdog line and test your 1.8 volt. If there's a short in here, you will not get this voltage, or if there's any issue with this line, you will not get this voltage. Okay, because this voltage is like it's like a letter, it's like a word that is sending. So now if this voltage is not there, your phone, that means your CPU is not giving approval to your power IC to work. Okay, so this is where we are going to end. I don't want to make long videos so that you can be able to at least watch and understand. Okay, I believe that you have learned something. Okay, so these lines are very, very important. Take your time, troubleshoot. Don't be in a rush, troubleshoot, and then you definitely find a fault that's coming. Okay, have a blissful day. Bye. See you in my next video.